Question 3 from the year mid 2025 paper 2CR. This question is about a compound called potassium permanganate KMnO4. A teacher makes a saturated solution of potassium permanganate using this method. Okay, so the teacher adds 25 centimeter cube of water at 50 degrees Celsius to a beaker. So let's just mark the important points down. The volume of water is 25 centimeter cube and the water is added at a temperature of 50 degrees Celsius to a beaker. The teacher then adds so the teacher then adds solid potassium permanganate. One spatula is basically some sort of a spoon, right? That you in chemistry that you use to add something, okay? At the time while stirring until the solution is saturated. Okay, so if I was to visualize the overall process, then it would look something like this. So basically, here's a beaker, okay? And the beaker is 25 water at 50 degrees Celsius. Okay, so the volume of water is 25 degrees Celsius and the temperature of water is 50. Okay, so maybe the person is heating it with a Bunsen burner flame, right? They explicitly didn't tell anything about it, but assume it was being heated. Okay, it was basically being heated by a Bunsen burner. Just a moment, let me just fix this a bit. So basically, it was being heated with something. Okay, we basically do not need to know what, but it was right. Then what they did was they were adding this potassium permanganate using this spatula, right? They were adding this pot. No, well, it isn't rounded obviously in round shape, obviously, but yeah, something like this. It was they were then adding this potassium permanganate one spatula at a time, and while doing so, what they were doing was just a moment. While adding it, they were basically mixing this thing up, okay, to ensure that all of that solid that was being added dissolved until there were some remaining solutes left, right? And that is basically when a saturated solution is formed. So in a saturated solution, there is going to be a surplus amount of solute that won't be dissolved in the solvent. Okay, so yeah, give the meaning of the term saturated solution. A solution where no more solute would dissolve. It is basically a solution where no more solute would dissolve. A solution uh, solution where no more when no more solute will dissolve. Okay, moving on. It says that give a reason why crystals form. Give a reason why crystals form when saturated solution cools from 50 degrees Celsius to the room temperature. It says that when the solution is basically cooled from 50 degrees Celsius to 25 degrees Celsius, why the crystals started to appear? Because the solubility decreases as the temperature decreases, right? This is because the solubility decreases. This is because the solubility decreases solubility decreases as the temperature decreases. This is because the solubility decreases as the temperature decreases. As the temperature decreases. This is because the solubility decreases as the temperature decreases. Okay, moving on. It says that It says that a teacher pours 25 centimeter cube of a saturated solution of potassium permanganate at room temperature into an evaporating dish. Okay. The teacher leaves the solution until all of the water has been evaporated. All right. The teacher records the mass of the evaporating dish and the mass of the evaporating dish with the dry crystals. Okay. The mass of evaporating dish is this, and the mass of dry crystal is this. Understood. So calculate the solubility of potassium permanganate in grams per 100 gram of water. So what basically means is that, first of all, what you have to do is you have to find the mass of potassium permanganate. So if you were to visualize this question, it would look something like this, right? So this is an evaporating dish. Okay, and in this dish there was this solution of potassium permanganate, and it was left to evaporate, and as it would evaporate, the water is basically going to evaporate. Okay, and as a result there is going to be the dish again. Now there is going to be the dish again, but at this point of time there is only going to be the solute, right? The crystals of potassium permanganate over here. So what was the mass of potassium permanganate in this? Okay, so how you are going to do this? You have the mass of the dish, right? You have the mass of the dish, and you basically have the mass of the dry crystals and the dish. Mass of the dry crystals and the dish. What you're going to do is you're going to subtract this and this together. So what would we get? This and this would cancel out, right? So this minus this. Okay. So if you were to minus this and this, what would cancel out? Evaporating dish and evaporating dish. You were left with only dry crystals, right? So you basically found out the mass of potassium permanganate. Okay, so the mass of potassium permanganate is gonna be mass of KMnO4 should be equivalent to what? Should be equivalent 65.35. 65.35 minus that, minus 64.10. 64.10. So the mass of potassium permanganate would be 1.25 grams. 1.25 grams. Okay. So the mass of potassium permanganate should be 1.25 grams. Now comes the catch. This mass of the potassium permanganate was in this volume of the solution. Okay. But in question, they asked you to find the solubility of it in 100 grams of the solution. They have given you a conversion unit as well, right? So this would simply mean that 25 centimeter cube would simply mean 25 grams. This would simply mean 25 grams. Now you could say, why 25 grams? Okay. So basically what you have given is density equals to mass by volume. Now you all basically know about this since our IGC, since a very long time, okay, from physics. So you basically have the density of water, and you basically have the volume of water as well. How? 25. And you have the density of it, see? So you could easily substitute this thing together, right? So 1 equals to mass by volume. So mass is gonna be equals to 25 grams, okay? So you have found this. So in 25 grams, there is this much of potassium permanganate that was soluble, okay? So in 100 grams, how much of the potassium permanganate would be soluble, okay? So basically unitary method, what you're going to do. In 25 grams, you basically have 1.25 gram soluble, 1.25 gram of KMnO4. KMnO4, that is soluble, right? So in 1 gram, you should be having around 1.25 divided by 25. 1.25 divided by 25. Therefore, in 100 grams of water, therefore in 100 gram, you should be having 1.25 divided by 25 times 100, right? So this should give you a value of 1.25 to 25 times 100, 5 gram per 100 gram of water. 5 gram per 100 gram of water is the solubility of potassium permanganate. Okay, so 5 gram per 100 gram of water. So this is the solubility of potassium permanganate in 100 gram of water. Moving on to the next part of the question, it says that um, the equation shows the thermal decomposition of potassium permanganate. Okay, it forms these, and these. Describe a test to show that oxygen is produced inside a glowing splint. Okay, and it relights. Uh, so you basically insert a glowing splint. Insert a glowing splint, and in the presence of oxygen it relights. Now you basically do not need to write about this, okay, because they haven't explicitly asked us to basically write about the positive test, okay, but let's just write this down. In the presence of oxygen it relights, and in the in the presence of oxygen it relights. The glowing splint relights. The glowing splint relights. Okay, so moving on, calculate the MR of potassium permanganate. Okay, so if you go to your predictable, you notice that the MR of this, the molar mass of this is going to be 39. For manganese is gonna be 55, and for oxygen is 16. How many oxygen are there? 4. How many manganese are there? 1. How many potassium are there? 2. So if you calculate, add all of this together, you would basically get the MR of the compound, right? So let's just do it. 39 times 2. 39 times 2 plus for manganese, this is gonna be 55 times 2. 55 times 2 plus oxygen, this is gonna be 16 times 4. So 16 times 4, right? So this should give you a value of, give me a moment, 9 times 2 plus 55 times 2 plus 16 times 4. This should, just a moment, am I right? So 39 times 2 plus 5 plus 16 times 4. This should give you a value of 197. So this is basically the answer of this question. So the MR is 197. 197. Okay, the MR is 197. Now, it says that potassium permanganate is an oxidizing agent. Give a reason why potassium is an oxidizing agent. Now you basically have to understand what basically is an oxidizing agent, right? Now, an oxidizing agent, let me just break this down. An oxidizing agent oxidizes other substances. It basically oxidizes. An oxidizing agent oxidizes other substances, but itself gets reduced. Now, this is the definition for oxidizing agent. Okay, now what is oxidize or oxidation? So let's just try to write this down. This could mean gain of oxygen, gain of oxygen, or loss of hydrogen, loss of hydrogen, or loss of electron, loss of electron, right? This is what we refer to as oxidation. Now, on the other hand, then what basically is reduction? Reduction is basically loss of oxygen or gain of hydrogen, gain of hydrogen, or gain of electron, gain of electron, right? Now, as we know the definition of oxidation and reduction, and we also know the definition of oxidizing agent, so this should become extremely easy for you to understand. Now, this is why an oxidizing agent oxidizes other substances but itself gets reduced. Loss of oxygen, gain of hydrogen. Okay, let's just see. Mhm. Let's just see for homework. This is for 1 mark, okay? So, what you could see over here is that this thing initially had 4 oxygen, right? But see, oxygen is being produced over here, which means that this thing is losing oxygen, loses oxygen, right? So why is this oxygen coming from? It is coming from the reactant. It loses oxygen, right? So, yeah, loses oxygen. Okay, so this brings us to the end of question 3.